Coming live from the command center of JW Solo USA. So what we're going to be doing here, we're going to simulate something, or we're going to utilize some battery power that we already generated before. We built this battery power, but we never tested the battery power. There we go. This is the Panasonic batteries that I got from Battery Hookup. Woohoo! Yeah, the Panasonic cells. So it's a 54.6 volt. I built this thing, which is a 6 in one string, 6 on the other string. They're all parallel though, but no BMS is required or imported into this system because I don't want to use a BMS. I know I have so much questions about this, and this battery bank is just about 76.8 kilowatt. So you can see, I think, a typographical error right here. So, okay, no, okay, that is full discharge. That's a full discharge is a 36.4, which is a 2.8 volt per cell. So we built this is a 3.694.08 kilowatt hours at 4.2 volts per cell. So give us this thing here. So lithium, I think it's a lithium ion or batteries. So you remember this battery bank I built. Look at that. I put it in a dolly. If you haven't seen this thing before, a solar battery bank on a dolly, something like that I said, or solar battery bank on wheels, something like that. Look for that video. So all in parallel. These batteries are all in parallel. All the wires coming from each module here, because there are 12 modules. So you can see all the way 1, 2, 3, 4, 5, 6. So 6 on this brick right here and 6 here, and they all parallel come to a breaker box here, a breaker disconnect. So I use this one, 150 amps DC breaker, and all the negatives comes to these buses here, bus bars. So you can see these are 6 gauge wires, and I use a 2 gauge wire for the parallel. All the parallel go into 4 gauge wire. 2 gauge wire, 2 gauge wire, 2 gauge wire, and out is a 6 gauge wire, and come all the way and parallel here. So that's why we're 1, 2, 3, 4, 5, 6, 6 of them. Okay, and 6 of them here. So it's all connected. So parallel, 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 parallel. So if you parallel 2, 4, 6, so you have 3 wires. Okay, 6 batteries. If you parallel them, you're gonna end up with 3 wires here. So they parallel. Anyone they parallel, I took one of the wires out from here and bring it all the way down here. So that gives her the 12 wires here. So 6 and 6 here, positive, negative. So this is what I've done, and this is what we're going to be using into these VEVOR 5 kilowatts inverter charger. So I've connected this cable extension cord, and I use it right here. Like my previous video, we used the VEVOR with these batteries here. With a 48 volt battery bank. We charged these batteries, but you guys didn't see these ones when I charged them. As soon as I finished charging this that video, I thought about so that we can put these batteries to service, because we never tried them after all the connection I've done. But I kept them. I have to make sure the battery, the breakers, if you put it this way, now the battery all turn off. So it's not gonna able to balance the batteries, the cell, the modules. So what I've done, so I have to make sure I leave the breaker on by doing so, because this is how the batteries are all tied and parallel here. So all the power is almost like going out to the inverter, but it's not going there. It stays right here. That keeps the batteries contact. Each module now is tied into here just like this. So I have to leave the breaker on all the time. If one module is about to be drained or is losing power, is always balanced. Though it's already on parallel, but they have to tie somewhere else. That's why I use this, and I have to turn this one on. and all the wires here. This is a temporary setup. So like I said, so don't think it's a messy work. I don't want you to discredit me for something. And this is for the solar. And I'm not done yet. It's just a test. So we have the transformer. Since we live in North America, we want to make sure that we use the transformer from 230 to 120 volt. So I switched the jumper right here. So now the input, so is the output coming from here and goes to the transformer. So it's the input now. So we bring in 200 volts. So, or 220 volts right here. Move this one here. 220. So 220 coming in, and it's going to be given out 120 volt AC North America. Then we can take this power from this side. There's a lot of conversion, which is a loss. That's why I said I'm not recommending someone use a transformer in between when you're using batteries, because the transformer is going to eat up the power. It's just like a vampire sucking everything. Even if there's no power going anywhere, this one is still powered. It's still in a standby all the time. So we're going to use the side here. So for the 120, we're going to be using this extension cord right here I made. So we're going to plug it here for the 120 volt. But before doing so, we have to use the meter first and test the output coming here. We don't want to do any risk. We don't want to take any risk. So we're taking 120 here, right here, a single phase. 120, one leg, because here's a 220. If we want to send this one to maybe a breaker panel, we would be able to do that. The output at the 220, because leg 1, leg 2 here. So this one gives you the 220. Okay, look at this massive sink, heat sink. So what we're gonna do now, we're gonna turn around here and bring the power to this power station, because we want to deplete the batteries. We want to drain the battery. But I'm not going to just do like other people do, a battery test or load test, put in a heat gun or some things just to burn the power. No, I'm not doing that. I can reverse the power, recycle the power, because this is what the battery is sitting at right now, 31 volts. From this 24 volts. So we're going to take this wire right here. So this is the one that I use for the charging, and it comes right here to the outback. So the outback is going to feed into that, and the outback going to take this one. This one has a low frequency. This is a low frequency inverter, the outback. So it's going to take the power and charge this battery bank here, which is the Volkswagen e-Golf batteries. There's about 12 of them in here. 6 in parallel, 6 in parallel series. That's why we have 2 bus bars here. Smart shunts made by Victron. So the smart shunts, one is for the, this is for the e-Golf Volkswagen, for the Ford Focus, and this one is for the e-Golf. So that comes right here. So this is my tech station, like I was saying. This is the this is the Ford Focus batteries. So they are tied in the 24 volts. And if you haven't seen the video, go back and look for the videos. But I can't able to break down everything for you because I don't want the video to be too long. It's already 8 minutes. So it's 272 amp hours. So the Volkswagen e-Golf 6 in parallel series. So it's 450 amp hours. So 450, so we're talking about total about 712, something like that. 712 amp hour battery bank. Now we're going to charge that by depleting these batteries over here. These ones we made. So we put them into a test for the first time by using a transformer and by using a VEVOR inverter. Stay tuned. Like and subscribe. JW Solo USA. Talking really be faster because I don't want the video to be longer. I want you guys to see this and enjoy it. So we have the disconnect right here, another safety coming from the battery from here. If we pull more power, these breakers will pop. Yeah, so it's a triple pole, like I do double pull throw, whatever, double throw. So this is a triple, 3 breakers in one. You see that this is one and this is another one here. So that's what we did. So one is going for one string of this here and the other one is going on that. It will pop if there's a main breaker to do whatever we are about to do. It's 160 amps here and this is 150 right there. So let's see how everything works here. Like and subscribe. Now we have a fluke meter here. We're gonna make sure that the fluke meter, we're gonna check the power first here that's coming out so that we can send any unwanted power that our machines cannot handle. So 2 inverters are working in conjunction to each other, though we have 120 volts American and 230 volts international. Now I already have the probes there. I'm gonna set this thing to the AC meter right here, and now we already have them guys already set up right there. They're on already. We're gonna throw this breaker and this inverter is gonna turn on. All right, watch this. Okay, now the power comes through and we have to still fire up this little button right here to turn the inverter on. There you go. The inverter is already on. So it's gonna read 230 volts, which is the output of the power this inverter is outputting. So there you go. The relay kicks. Okay, I have to push this button. That's the voltage of the batteries right now. Here goes the 230 volts right there. So I had it on the power saving mode and I turned that function, which is option number 4, was SNU. So if you press and hold right here, the enter button, so you scroll to number 4. So number 4 is the SDN. But if you want to put it to power saving mode, So power saving mode is going to be SEN. So push enter, then escape. See, it's not reading anything, any 230 volts at all. It's not reading. So I'm going to put it back there, press and hold the enter. Then we go to option number 4. So we push, we went too fast. So we go option number 4 and we push enter and we scroll down to SDN, enter and push escape. So now the voltage is there. So I had it in power saving mode so you can just eat the batteries. So now we already have the meter sitting here and we're gonna turn the transformer on. There you go. Did you hear that honk sound? So it's 120 volts right now coming out from here. Say 113. So let's go back and put the probes right here. It says 236 volts, 37, which is you want to do like put in 230 volts so you can power 230 or something. So 120s, you can just use this guy. You got to push both legs at the same time. So there we go. It's ready to engage and it's going to be showing us how many amps we're pulling from here. So we already have the transformer on. We turn this one off at first. So let's come here and grab this wire and now it's going to initialize the out back. Plug this one right here. We know that our connection is correct. And let's keep the screen on and let's initialize the out back. Now the out back, Let me bring you here. You see, it started flashing. The AC line, it says there's power coming in. Then it's gonna click. There you go. Did you hear the relay? So that now it says charger on. You have two lights and you're gonna see the power started ramping up here. Look at this bar. It's moving now. There you go. So the outback is pulling and it goes. I can hear the VEVOR on, pulling 2 kilowatts, charging the batteries. See what is going on right now. You see the power, 30 amps, 20 amps is going to each battery bank. You can hear the sound. The fans are running, not loud at all like other people probably think. And we pulling. Let's check the meter here. See how much power bring. Now we'll drop at 53.4. So the load is 55% right now. 55, 58. So we pull in a 2.34 kilowatt. See that? 2.34 kilowatts. We pull in. So we pull in about 47 amps from the inverter. Man, this is cool, right? It's cool. Yeah, JW Solar USA has done it again. Let's check this guy. Cold to the touch. And I can feel the air blowing from this side. It's not loud, taking almost 2 point something kilowatt. It's cold to the touch. The batteries, the wires are all cold to the touch. So we are testing our battery bank here. We're going to deplete this battery and recharge it again. So someone was asking me a question about if I'm not using a BMS on this. They said, the seller said, you cannot stack these batteries. You can't stack it. I said, I can do whatever I want. This is my project. This is my business. And this is what I do. Battery hookup don't tell me that I don't have to stack the batteries. They never said it. So I don't know where this individual came from and trying to tell me or control me or dictate for me what am I supposed to do, what I don't supposed to do. So I'm doing it anyway. So the transformer here is taking the load. It's a 5 kVA made by 7-star, and the plug is cold to the touch. We're taking 230 volts out of here. We're transforming it, step it down to 120. We pull in 2 kilowatt from this. The heat sink is really cold to the touch. So let's go back here. Look at that. We're pulling 2 kilowatt. Pretty soon the fan's gonna start kicking up into this outback due to heat buildup. We get all the breakers cold to the touch, all the shunts. We charging the batteries. Yeah, I like that. So if you want to see where renewable is doable, check with JW Solar USA. We're bringing you all the latest right here at the command center in Minnesota. Look at that. We bring 29 amps and 25 amps. So the Volkswagen e-Golf is always there, and this guy, they're just sharing the power. If I turn one of the breakers off, we'll charge the battery bank, the other one, so fast, and turn the other one back up. They just bounce all the way and charge all the way up. The batteries all blended together parallel. So look at that. We don't have no sun today. Look at the production. Nothing. It's cloudy, dead, dark. And only 40 watts there, 40 watts there. And look at that. Man, it's working. I love it. There we go. The fan just kicking. And look how all the blue lights are flashing. You might not see it because of the flashing, because of the camera light. So the Outback is cooking. We're bringing 2 kilowatts here in the system. This is awesome. Awesome, awesome, awesome. We are now 31.4. Oh, I forgot to put the timer. I was gonna use the timer to see exactly how long we're gonna go with this. So it's 2.3 kilowatts, and the batteries are now 52.5. We start at 54 point something. Well, they are not 100% charged, so don't trust this meter right here. They don't even have shunt, so it's always off. It throws you off completely. And likewise, this crazy one here is now, I just saw it went up all to about that, very close to the 100, but it never shown accurate reading. So yeah, so let's see how it goes. 2.3 kilowatts, and we're gonna have a lot of efficiency loss all the way. And after we're done, we're gonna reverse the power again. We use the 220 volts coming into this transformer, and we change the plug from here to 100. Okay, that's the one that's coming in, and we're gonna send this power so that this power will take the 120 and bring it in to the inverter. Okay, we're gonna take this, like we did the last time, and plug it to the transformer right here. We'll take the transformer and plug it direct to the wall. But this is, I cut the wire already so that I can able to do that connection right there. So we're gonna charge up these batteries again and ready. You know, these are gonna be our load test or capacity test on this battery live here at JW Solar USA. The fan is blowing, man. You see them, they're going crazy. But everything is cold to the touch. The terminals are cold, and it's cool. It has a lot of things here. Vent. This is the intake, and they have another intake right here. Intake on the sides right here, the exhaust, and it's blowing the power. It's taking it from the top and blowing it up. A lot of people say they don't ever understand like the technology, what MPP solar, why they did. It's supposed to take the power and push the power back up. That's how some people say. I don't know. It's the reverse, but it's taking the power there. When the power draws, the fans are drawing like a turbine, and it's cooling the equipment from that side. When it's pulling the air in, it get cooler and just take the warm air out. But this air is really cold, just like being in a car. Okay, like you have your fan on in the car or your air conditioning. Yeah, or when it's raining, you have the fan just on. So this is what it is, guys. Thank you for watching. Like and subscribe. JW Solar USA, Command Center in Minnesota. We've done it again. Our test is working. Cool to the touch. We are not pulling a lot of amps here. Oh, I didn't even have my clamp meter. I would have put my clamp meter here to see how many amps we're taking from this thing. Hold on. It says it's pulling 23, 24 amps, but I don't know why it says AC here. I don't know if there's anything I have to change, or maybe this is not a DC clamp. I don't know why. Yeah, it's just an AC one. I think it reads only AC. So the fluxo on an AC, like we're pulling at 23.9 amps. On the positive side, on negative side, 24.1. Let's go back to the positive. I saw 24 earlier. Yep, so it says AC. I don't know why. Amp AC. Okay, well, that's all about it on this test. Like and subscribe. It's a long video. I try not to, but the batteries, the wires, and everything, the breakers, the disconnects, everything is just running fine and dandy here. So the batteries are dropping 51.7, and we're pulling a 2.8 to a 2.3 kilowatt. So like I said, the batteries are not charged. Like this is the first surface charge. You never get a cycle yet. So let's see how far we're gonna go till this system shut down. Look at the shunt reading here. The state of charge is wrong. So there's a lot of loss of efficiency right here, because we take in a DC, bring it back into this, we turn it into AC. From an AC, this one got is a high frequency inverter, and it goes to a low frequency inverter here, and it takes back there from the low frequency, and it takes it out from 240. It lost efficiency there, 230, and it shoot it all the way back to 120, and goes back to another inverter there to the outback, and which the outback is another low frequency inverter. It's taking that power, a low frequency, and shooting the power back and convert it from AC to DC to charge the batteries. How much loss you talking about here? It's ridiculous. Don't do this. This is just an experimental thing. So I've seen a lot of people doing that, put the transformers in between their stuff. Don't do that, because it's a low frequency. The outback is a low frequency. It's a low frequency, and you get a transformer is a low frequency, but the 5 kilowatt inverter is a high frequency. So it's a lot of ups and down, up and down, up and down. Doesn't make sense. At the end of the day, people that has larger battery bank, they say, oh, it's not a problem, I have a big battery bank. Okay, kudos to you, but I would never do that. Okay, so overseas they depend on the sun. Some of them don't have the generator, and what do you think? They just use the wait for the sun to come back and filled up, because the sun is abundant. You know, they're sitting very close to the equator, so they have the sun. No worries. Okay, that's it. Bye. Like and subscribe and share this video. Alright guys, we started having the alarms are flashing, because since I shut off the alarms, the noise, the beeps, we are still pulling 2.17 kilowatts, and code 4 is showing us, I think code 4 is supposed to be low battery. Exactly, if you look at code 4 that was flashing right here, it's a low voltage. Battery voltage is too low. So, oh, now it shut off. We just lost the power. That means we deplete the batteries now. So look at the code here, the chart is going to tell you, and we see the high voltage is going to be 3. So these are all the trouble or fault reference on the manual. So like I said, we already put some kind of power to the batteries. They are not full, because mind you, this is just about 76.8 amp hours, which this machine requires to have 87, at least. It's a 48 volts, it's 87 as a standard battery. You have to have that. So if we have only a 76.8, it's not gonna last. So if you pull in a heavy load like that, 2.3 kilowatts. So the system shut off. Turn off the main battery disconnect, and it's already powered down. The transformer is down, and if we check right now the voltage on these breakers, so I set up the batteries to charge, to disconnect at 48 volts. So low voltage cut off. That's why you have that signal. So batteries are empty, and now the inverter is powered off, powered down, and we have to do the reverse now. We want to use this machine to charge. We have to use the reverse energy transformer to charge this battery bank, or we can use another device to charge this battery bank instead of going through a reverse process. which is taking power from the grid. To do that with the low frequency or transformer cylinder, we're going to be burning more kilowatts charging this battery bank. So as of now, we can leave it this way, and we don't want to keep the batteries too low like that. We have to bring them up and charge them back up. Thanks for watching. Like and subscribe.